Last few, that's okay. This one shouldn't be too bad. Oh, did I write it wrong? No, I didn't. I just rewrote the. Yeah, it's not done yet. I just rewrote the cube root of m squared is m to the 2 thirds. What's this one? 2. Why? Because notice this. I did this earlier, but 4 squared is 16. That's how you can always think of it. One of my colleagues somehow makes this into a snail, and it's like the snail method. Whatever. 4 squared is 16. The answer is the power. So this is why. That's the answer. This is why. Don't just write this and never tell me what the answer is. If you just did this, you're going to lose points. You go, no, you didn't tell me what the answer is. You got to show me that you understand. The answer is the power. What about this guy? Yeah, anything to that 0 power is 1. Right, so you can say the reason there is 7 to the 0 is 1. And then that guy is kind of related to this guy. 2 is really kind of nifty because you see a lot of symmetries with 2. What's the answer here? 4, because 2 to the 4th is 16. How are we doing? Is that? So please, I always hear people hating logarithms so much. They really aren't that hard. I can make them harder, but you just always go back to the basic question at once. Answer. This guy's kind of funny. The answer is staring in the face. What do I raise b to make it b to the 8th? Yeah. Here's the other way to look at this. Ready? B to the power and log base b are inverses. So they kill each other. The answer is 8. That's the other way to think about it. Or just go, well, they put the power, there you go. Right? And the reason this is because b to the 8th is b to the 8th. Wow. What about this one? This one shouldn't be horrible. Yeah, -1. 5 to -1 flips. So 5 to -1 equals 1/5. What about that guy? You just got to take one more step past what we just did. Yeah, if it was this, the answer would be 2, and to flip it, I got to make it -2. So you guys see how to piece this thing together. And that's another one like this. The big thing with that one is remember to write it in that way so then you can see what the power is. And then what's the answer? 2/3. Yeah. I think you said that, but somebody else did. Yeah. So these cancel, or m to the 2/3 is m to the 2/3. That's groundbreaking. Yeah, I like it. So let me show you. Let me show you a couple more things. Then I'll let us out of here. I can go get a drink. That was somebody saying, yes. That's how I'm going to take that. So what if let me think, what was I going to do? Oh, okay, here. So this is interesting to watch. What's log, let me do something besides 2, because 2 is just 2. It's log base 3 and 9. 2. I know I'm expecting a little bit too much right now, I'm sorry. The idea, you got to think about it. So right now it's almost like learning a new language. You can't just start talking, you got to think first, translate, and then say. So you see, translate, what power does 3 need to be? 9? 2. So I have to give you that time. What's log base 3 of 3? 1. What's log base 3 of, well, shit, I should have done something better. Let me start over. Log base 3 of 1 is 0. Log base 3 of 1/3 is -1. My point I'm trying to make, let me do one more example. If that number is bigger than the base, you're going to get a number bigger than 1 as an answer. If it's, well, I could do this. All right, let me see if you guys are cool with this. Let me add 1 in here. All right, this is a little bit funkadelic. What's log base 3 of the square root of 3? How do I have to rewrite that so I can see what's going on? Since logarithms are all about what? Logs are all about exponents. So I'm going to rewrite this in exponential form. 3 to the 1 half. And what's that? 1 half. Log base 3 of 1 is 0. Log base 3 of 1/3 is -1. I'm just going to do those. We did problems like that earlier. Guys, with me? What I want to point out is this. You don't have to get what I'm about to say, but it really makes you quicker on checking answers and making sure that it kind of makes sense. If the input is equal to the base or higher, you're going to get a number 1, 2, 3, something like that. It's kind of cool. The answer is a fraction if it's in between 1 and the base. The minute the input becomes less than 1, it's got to be some negative number. That's the only way to get something whole to become less than 1 is to flip it. Again, you don't have to understand this. You don't even have to think about this ever again if you don't want to. You can still do logarithms, fantastic. But the more you get this kind of idea, the easier it will be to not make certain mistakes. That made grammatical sense. Good. Maybe. I'm pushing a lot at you today, I know, but I desperately want you to see how relatively simple logarithms are, especially if you heard any horror stories about them. They are nothing. They really aren't. Okay, I like it. Let's do one that might be, let me see if I can come up. What about this here? Log base 8 of 2. So this is one where knowing this would help a ton. The input is not 1 or smaller, so it can't be a negative. It's going to be some kind of a fraction. It's going to be some kind of a root. So watch this. What's log base 8 of 8? 1. What's log base 8 of 1? 0. Now watch. Ready? That's between those, so its answer should be between those. That's the point I'm trying to make here. So I know that if the inside is less than the base, but bigger than 1, the answer actually has to be a root, because the answer's got to be some kind of fraction. What's a fractional power? A root. So what root do I take of 8 to get to?
1/3.
Yeah, the 1/3 power, the cube root. That's when things start getting a little bit wonkier, right? When your input's smaller than this dude, but if it's bigger than 1, the answer's got to be a root. Then you can kind of change your way of thinking. Okay, I've got to think about it as a root, in this case. A root. Okay. Let me think. That might be... Yeah, we did pretty well. Okay. Yeah, not too bad. Yeah, that's plenty. That's plenty for today. So we got into 12.3. We are definitely doing all of 12 before the final. And we'll talk a little bit about those last 2 chapters. Okay.